Hey folks, this is part two for measures of central tendency. We're going to focus on actually calculating those measures that we talked about in part one, and we're going to do that in SPSS. So if you don't have SPSS downloaded, please go. You're going to need to download that and make sure you have it installed on your machine. I know you've seen this slide already, but I think it's important before we get started using a machine to do the work for us, we remember what statistics are about. Statistics is that logical application of math to solve a problem. You can give a machine any set of numbers and tell it to calculate a mean or to calculate a median or a mode, and that computer can do that for you. Whatever that program is, usually can handle calculations. Your job is to make sure that you are asking for the right calculations, the right statistic for the data that you're providing. Okay, so one last thing before we go ahead and actually calculate those measures of central tendency and SPSS. I just want to remind you that there are three measures of central tendency that we are going to be working with. They are the mode, which is the most frequently occurring value in your data set, the median, which is the value that splits your data in half. More formally, it is the value at or below which you can find 50% of your data once your data have been sorted in increasing order. And then finally, we have the arithmetic mean. This is when we sum all of the values that we have, and then we divide by the number of values. Those measures of central tendency need to be applied to different levels of data. The mode can be applied to nominal data, and it is the only measure of central tendency that we've covered that we can apply to nominal data. You cannot calculate a median or a mean for nominal data. A median requires that you have some idea of ranking. Some values have to be more or less than other values. With nominal data, those categories that are in there, they have no intrinsic value. So we can't say that one is greater than or equal to. Therefore, we cannot find a value at or below which 50% of our data lie because those data have no relationship to one another. Now, if we have ordinal data, we have that ranking. We can put the data in order, and then we can find that value that splits the data set in half. As a result, we can calculate a median for ordinal data, and we can still calculate the mode because the mode only requires us to count how many individuals fall under a certain value. Lastly, if we have interval or ratio level data, because they give us so much more information, particularly that the distance between values is meaningful and predictable or regular. In other words, the distance between 1 and 2 is the same as the distance between 2001 and 2002. That allows us to do the math that we need to do in order to calculate a mean. So with interval or ratio level data, remember ratio is just the same as interval, but we have a true zero, a meaningful zero, we can calculate all three measures of central tendency, the mode, the median, and the mean. All right, now let's get into SPSS and let's go ahead and see how we can calculate these. It's very quick to do as long as your data are set up to be used. Okay, once you open up SPSS, you should see a screen like this. The default will be an untitled data set. We can change that later when we save our file. Now, if you have a lot of data, you're probably not going to want to enter them by hand, but I just want to show you that you can enter data by hand in this data view, which you see down here highlighted. If we click on a cell, we can simply type. We can use numeric data. We can also use string data, and we can enter multiple variables. Now you see, as we enter a variable, SPSS will auto-create a name, and the default will be var some number of zeros, and then they will iterate starting at 1 all the way up until the last variable that you enter. You'll also see that there are some indicators here, some pictures next to the name. Those pictures tell you something about the data type that is in that column. You can see the ruler is for some numeric type. And you can see these circles, we get these when we have some sort of string entry. Now, I'm not going to enter a whole bunch of data here, or really, I think you should be a little lazier than this. So what I will do is import a data set by going to File and then Import Data. There are lots of different ways that you can import data. I'm going to import a CSV style. CSVs, or comma-separated values, are a very common way to exchange data. Now, SPSS will open up to a different location on your machine. If you have imported data before, it will default to opening up in the last location you used. I'm going to click on this CSV file. Actually haven't used this one before, so it'll be fun to see what's in here. Right. Okay, it will give you a little bit of a preview. This is kind of what the data look like if you were to open this file in a text editor. There are some defaults. That first line, we can tell SPSS that first line has the names of our variables. That's fine because that's exactly what we have here in this first line. We can tell SPSS to remove some leading spaces. So sometimes when you enter data, you may accidentally hit a space bar, or whoever was entering the data for you may accidentally hit the space bar at the beginning of typing their values. So we can remove those, and we can remove an accidental space at the end of a value, as long as that value is a string or text item. Now, because this is a CSV, a comma-separated file, the thing that tells SPSS where one value ends and another one begins is a comma. And we can also define how we indicate a decimal. Internationally, the comma may be used, but in the US, we tend to use a period. And then we can also tell SPSS how to find text values with a double quote, a single quote, or none of those. We're going to leave the defaults for those. And one last thing, SPSS will try to figure out what type of data you have in each column, and it uses a certain amount of data to figure that out. The default is to use 95% of the data. We don't really need to do that here, so I'm just going to reduce the amount of data to 30%. Caching the data locally allows you to recover data if the program closes unexpectedly, or if you just accidentally close it and forget to save. I'm going to go ahead and click OK because the rest of these options are fine. As you move on, you can get into more advanced options, but you will not need that for most of what we do in this class. So we'll keep the first line containing the variable names, remove those leading and trailing spaces. And just for kicks here, I've reduced the amount of data SPSS has to evaluate before it'll guess at the data type. And then we just hit OK. Okay, it didn't like I gave it too low of a value. Let's just give it 50. Okay, let's go with 51. It would help if I could read. All right, so we've read the data in, and now two new screens pop up here. This first screen that we see here is a log of what you are doing to your file. This can be helpful. For some of the assignments later, you're going to be copying and pasting that log into a Word file to show me what you did in SPSS. We'll see how this log changes as we go along. All right. So let's click back to the bigger screen. Now you can see all the data that were in that file. You can see each column. We can get a good bit of information in this view. We could also use the variable view, where we don't see the individual values, but we see descriptions of the columns, what the names are, what types they are, and with kind of tells us how many characters can be in a single row. This gets important for when you're trying to manage data size. It's not something we're going to worry about too much in this class. And here, SPSS is trying to guess at whether our data are scale or interval, whether they are nominal. And those seem to be the only distinctions that it'll really make here. So that means that you're going to have to do a little bit more work later on. Okay, let's go back to the data view. And for your first couple assignments, we're going to be using the Analyze tab to try and calculate some measures of central tendency and later on measures of dispersion. Before we calculate things, we should probably take a look at the data in these columns and try to familiarize ourselves with what we have. Some columns are numeric and the contents may make sense to be treated as scale or ratio. Age, for instance, it makes sense to treat that as at some interval or ratio level data. Hours of sleep, physical activity, caffeine intake, those all seem like they should be ratio data. Alcohol consumption as well. We have some nominal data here for smoking. It's yes, no. Family history of anxiety. Stress level, 1 to 10. So we're going to have to think about this one. What is that stress level? Is this something that is interval level? Or is this perhaps something that is rank or ordinal? When you get to your homework, you'll see more complete descriptions of these columns so that you can make an informed choice about how you treat them. For now, I'm going to pick something that is pretty straightforward and for which we could calculate all of our measures of central tendency. We're going to take a look at alcohol consumption. This is the number of drinks consumed in a week. So if we click on the Analyze tab and go down to Descriptive Statistics, then we can click on Frequencies. And here on this tab, on the screen here, we're going to select the columns that we want to analyze. For now, I'm going to suggest that you deal with these one at a time so that you can start to understand the output. Now I'm going to click on alcohol consumption, and I want to note that this is not showing up as a numeric variable. It is showing up as some sort of nominal variable. But let's just see how SPSS handles this. So we'll highlight the value and click the arrow to add it to the list of variables that we're going to analyze. We don't really need frequency tables, so I'm going to go ahead and remove that for now. And then I'm going to click on Statistics. And this is where we choose what things we're going to calculate. You could choose quartiles. You could focus on just measures of central tendency, which is what we're going to do today. I'll click on mean, median, and mode. And just for kicks, I'm going to add in standard deviation, variance, and range. We haven't talked about those in our lectures yet, but we will talk about them soon. So don't worry for now. I just want you to see what the output looks like. Once you've selected the statistics that you want to calculate, you'll click Continue, and then you will click OK. Now, it brings us right back to this log screen, right? And here we see the output from that analysis. For alcohol consumption, we have a mean of 9.73, a median of 10, a mode of 18, and then we have some values here for standard deviation, variance, and range. When you're ready, you could calculate multiple statistics at the same time. So it still has the variable we selected before, but I'm going to add sleep hours in. I'm going to keep the same statistics and I'm going to run it again. And now you see you get a table where you have the statistics down the left side and the different columns for which the statistics were calculated across the top. All right. Now let's try and really push SPSS to see what it can do. Let's add something that we know is not even a number. If we go back to the data sheet, we can see we have text in gender and occupation. Let's pick gender and let's add this to the analysis and see what happens. Again, we're going to keep the same statistics and then we will hit OK. All right, now we have a little bit of trouble here. So gender has values. It has 11,000 valid values, no missing values, but it doesn't calculate a mean or a median, and that makes sense. These are nominal data. We can't calculate a mean or median, but we should be able to calculate a mode, and SPSS cannot do that. In order for SPSS to calculate statistics like the mode on a variable like gender, we need to code those data so that they are numeric. So we could, for instance, indicate male as 1, female as 2, and anything else as 3. Or depending on your data, you could have 4, 5, 6, or more different values for gender. But you'd have to create that code, and then you would have to run the analysis on those coded data. We're not going to deal with coding data now. In your first couple assignments, I have already coded any data that you will need to be coded.